Hello student, let's try to understand our topic student. What is this topic is all about? Force on a current carrying conductors in a magnetic field. So what type of force is there on the current carrying conductor in a magnetic field that we have to understand student. So we have learned that electric current flowing through a conductors produces a magnetic field. The field so produced exert force on the magnet placed in vicinity of the conductor. French scientist André Marie Ampère 1775-1836 suggested that the magnet must also exert equal and opposite force on the current carrying conductor. The force due to magnetic field acting on the current carrying conductor can be demonstrated through the following activity. Here you see student. What the activity are there? Here this is the magnet north to south. This is the horseshoe magnet is there. This is what is the, here is the conductor is there, current carrying conductor. So what you are going to feel on it? Take a small aluminum rod AB using the two connecting wire. Suspend it horizontally from a strand. So you are taking the aluminum rod AB. Place a strong horseshoe magnet. This is the horseshoe magnet. This is such a way that the rod lies between the two poles of the magnetic field directed upward. For this, put the north pole of the magnet vertically below the south pole, vertically above the aluminum rod. Okay. So north pole should be vertically below and south pole will be vertically up. Connect the aluminum rod in a series with a battery, a key and the rheostat. So we should have the few things which we can understand, that there should be the battery to supply the current, there should be the rheostat also required, key also required. Now so battery, key, everything is there. Now pass the current through the aluminum rod from the B to A. You are passing here B to A. What do you observe? It is observed that the rod is displaced towards the left. It is the displacing toward the left, this direction. You will notice that the rod gets displaced. Reverse the direction of current flowing through the rod and observe the direction of its displacement. It is now towards the right. Why does the rod get displaced? The question is because current carrying conductors in magnetic field experience force. Okay. So a current carrying rod AB experience a force perpendicular to the length, and the magnetic field support for the magnet is not shown here. Now the displacement of the rod in the above activity suggests a force is exerted on the current carrying aluminum rod when it is placed in a magnetic field. It also suggests that the direction of force is also reversed when the direction of current through the conductor is reversed. Now changing the direction of field to the vertically downward by the interchanging the pole of the magnet, it is once again observed the direction of the force acting on the current carrying rod gets reversed. The direction of force. It shows that the direction of force on the conductor depends upon the direction of current, direction of magnetic field. Experiments have shown that the displacement of the rod is largest and the magnitude of the force is highest when the direction of current is at right angle to the direction of the magnetic field. In such a condition, we can use a simple rule to find the direction of the force on the conductor. Now in the activity 13.7, what we are going to observe, student, we considered the direction of current and that of the magnetic field perpendicular to each other. What is, student? Direction of current and the magnetic field are perpendicular to each other, and found that the force is perpendicular to both of them. The three direction can be illustrated through a simple rule called the Fleming left hand rule. According to the rule, state the thumb, forefinger, middle finger of the left hand such that the mutually perpendicular. If the first finger point the direction of magnetic field, the second fingers is the direction of current, then the thumb will point the direction of the motion or the force acting on the conductor. So here in the diagram we show this is the middle is the current, this is the magnetic field, this is the force. Now device that use current carrying conductor and magnetic field includes the electric motor, electric generator, loudspeaker, microphone, measuring instrument. In the next few sections we shall study about the electric motor and generator. Now see the question. An electron enters magnetic field at the right to it as shown in figure. This is the electron. The direction of magnetic field acting on the electron will be. Now we see student, this is the magnetic field line, that is forefinger. Direction of current will be the upside, opposite the direction of the electron. So what will be the force? Force will be the downward, student. Force out into the page. Now see the what is their option D. The direction of force perpendicular to the direction of magnetic field, and current as given by Fleming left hand rule. Recall the direction of current taken opposite to the direction of motion of the electron. Thus the force therefore directed into the page. So the correct option is option number D. So this is all about the answer, student. Thank you very much for watching.